In this video, we're going to talk about composition of functions using equations. So how do we evaluate when we have a composition using equations? So remember that compositions can be written one of two ways. We've got this open circle that looks like a multiplication dot and parentheses here, and I prefer it to be written like this. But remember, we have to go inside out, and so this reads x, or it reads f of g of x. Either way it's written, but x is our input into the g function, and then that output is the input into the f function, or whatever this first function listed here. So if we look at our examples, we've got these two equations for f of x and g of x. So we want to find what f of g of x is and g of f of x. So notice how our input is not a specific value. We're still just using the variable x. So these are going to end up being a little bit more complicated. If it's a number, our output is typically just going to be a specific number, provided there's only the one variable. But in this case, it might look a little more complicated, so we still want to simplify whenever possible, combine like terms, distribute, things like that. So the first example, f of g of x. Well, I always like to rewrite it like this, so it's easier for me to see. I plug in my x value into my g function. Well, that's just going to give us this x squared minus 2x plus 6, right? So that's my output for g of x, and now that is going to be the input into the f function. So now in our f function here, this input gets plugged in for x right here. So we get 3 times x squared minus 2x plus 6, and then minus 4. So then we distribute, combine like terms, and we get 3x squared minus 6x plus 14. Okay. Now, just because we still have the f and the g function once each, just by switching this order around doesn't mean we're going to get the same answer. So now we have to plug x into our f function, which we know gives us 3x minus 4, and that output now gets plugged into our g function. So we plug 3x minus 4 in for x here and here. And now we've got a little bit more work to do than we did here. We have to do 3x minus 4 times 3x minus 4, and then distribute the negative 2. Once we combine like terms, so we end up with this here when we distribute or square this binomial, and then we distribute here. We get these two terms plus 6, combine them all, and we get 9x squared minus 30x plus 30, which is clearly different than this one here. So now what's a little bit simpler is when we have an input that is an actual numeric value. So this is asking us for g of f of 1. Recall that g of f of x gave us 9x squared minus 30x plus 30. So we're going to come back to that. I think typically you're going to see compositions where you've got a number here as your initial input. So we're going to plug 1 in for our f function. So we plug 1 in for x right there. Right, so we're really doing g of f of 1. F of 1, when we plug that in, we get 3 minus 4, which is negative 1. So now negative 1 is what we get from f of 1. So that is our input then into our g function, right? So now we input negative 1 in for x in our g function, and we end up with an answer of 9. Now, since we already had g of f of x, which you're not always going to have, we could just take 1 and input it into what we found for g of f of x, and that would have also given us 9. But typically, you're going to end up with something like this or this, not both.